Hello, in this video I'm going to go through lab 3, which is the Ohm's law. In Ohm's law lab, we basically start with the resistors and study the resistors, and then we'll move on to the Ohm's law. So first part of this lab is the theory. I'm going to quickly go over the theory. And the theory we're talking about the resistance of a material is basically dependent on three things. One of them is the resistivity of the material. R equals rho, which is the resistivity of the material. So for different materials, we have different resistances. And also it depends on the geometry, which is the L length, and A, which is the cross-sectional area. As you see in this picture, depending on what geometry it has and also on what material you have, you're going to have different resistances. And then once we fix the resistance, we look at the Ohm's law. The Ohm's law is saying that if you put a resistor in a circuit and apply a voltage and across the resistor, you're going to have a current flowing into it. So that current is dependent on the voltage that you apply. Increasing the voltage, the current is going to increase. But there is a ratio. That ratio is saying that the ratio is the resistance of the material. So R equals V over I. We can also write it in the form of V equals IR. V is in voltage, I is in ampere, and R is in ohms. If you put the R, I mean, many times, R is put in kilo ohm and then I in milliampere, which kilo and milli cancel each other, which still gives you a V in voltage. But just, depending on the which units you're using, you're gonna have you should be careful about the unit of the other unknown. So a resistor is symbolically shown, schematically shown like this, but it is also, a commercial one which you can go and buy is looking like this shape as you see when you connect it to a circuit. So the first part of the lab is looking at different resistances. If you click on the link that I have provided over here, it opens up the interface as you see in this picture. So here is the first part of the lab, which you're having. The resistance is shown as rho L over A, and rho being resistivity, L being length, and A is the cross-sectional area. So what I'm expecting you to do is to fill out this table. So I actually had filled out just okay. So as you see, the first part, whatever it is, the first one is the example I have given you. As you see, it is basically nothing changing. But what I want you to do is to change the resistivity, which means change the material, the second part, and then keep the rest of them fixed, and then see how is the resistance changing. So let me, for example, do it for one case. So if I change the resistivity to go to 0.63 or 0.63, then I see that the resistance of the material or this configuration or material is going to be 0.84. It is 0.84. So, and then you increase it more and more, and then you see how the resistance is changing. So I increase it to another data point and another data point, and then I see that. Okay, so when I want to go to the next part, I just reset it, and then this time I want to increase the length. So I go, previously it was 10, then I go to something else. You just, when you are changing, make sure that you change it little by little, or decrease it, either decrease it or increase it, so that you see how the change is affecting the resistance. Okay, so for example, in this case I put it in 11.83, and then I'm reading the resistance to be 0.789, and then you keep going, you increase and increase through the more data points, and then you fill it out. And then for the last part, I want you to only change the area. So I'm going to reset it, and then I'm changing the area. I go, for example, if the area goes to 9.34, then the resistance, I read it as 0.535, 0.53535. And then you also fill out the whole thing. So the first thing I'm asking you over here to insert a screenshot for the for one of the cases in the table above. So I'll go over here in insert screenshot, and then you take this, you go on the screen clipping and take the and clip it from wherever you want. For example, you want to show me that this is one of the cases, and then I see, yeah, this is the case regarding this one. So I see if you have made any mistakes, then I would be able to help. And then I want you to go back and look at your table and then answer these questions: how the resistance is changing with the resistivity, length, and cross-sectional area, and then put your answers there by highlighting the answer. Okay, so the next part is the Ohm's law, where you have basically, I want you to go to the second environment, which I also have provided those files of these environments. You can always go online, or you can download it from the file that I have given you. So pretty similar to what we have done before. So I want you to basically do so I have already filled out these. So what I want you to do is basically, this is the initial case where you have 4.5 and 500 there, and I want you to increase the one at a time and see how the current is changing. So if I'm increasing, for example, for the voltage, it is already 4.5, so I'm going to give it two more numbers, 10.4. For example, if I go to 10.4, then how much is the current? The current is going to come out as, oh, sorry, if I put the voltage 5.2, the current is 10.4. 10.4 is the current, and the voltage was 5.2, 5.2. And then if I keep going, for example, another 6.3, let's say 6.3, then the current is going to be 12.6. And then if I keep going, I give it another 7.4, for example, I have 7.4, and then the current is going to be, for example, how much? 14.8. 14.8. So, I mean, you just fill it out. I'm filling this part out because of a reason. I mean, you'll see in the next part. And then go back to the initial numbers, and then this time change the resistance. So I'll just go back, and then now I'm going to go, for example, the first resistance, second resistance, third resistance. It doesn't necessarily need to be uh, equal changes, but I mean, as long as you have three numbers, you just fill it out. That's it. And then I want you to put the screenshot just like before. You go insert and then put the screenshot, and you go, if you insert, you go screenshot, and then you go to screen clipping, and then you should be able to clip the area that you want to put in your report. So here is the, for example, the one you want to show me, and then answer the questions. So, but over here, I also want you to do something, and that is plotting the current voltage curve, which is also called IV characteristic curve. IV characteristic curve shows you what is how is what is the resistance. Basically, the resistance is going to be 1 over the slope of this line that you're going to plot. In order to find the slope, you need to do rise over run. But first, let's put the data points in. So it is very easy. I've already embedded an Excel sheet in it. So you can either go to data, edit data, or edit data in Excel. Both are going to be pretty much the same. So I'm just going to put edit data in Excel. So here I have basically the voltage and the current. I have started from 0 and 0 because that is the initial. I mean, no current, no voltage, no voltage, no current. So it is 0, 0. And then for your first data point is going to be 5.2 and 10.4. 5.2 and the voltage, and 10.4, and the current 10.4. And then the second data point 6.3, 12.6, 6.3 and 12.6. And the third data point is 7.4 and 14.8, 7.4, and 14.8. So those are going to be your 3 data points you have. You could include the initial data point as well, but that doesn't matter. You could start from 4.5 and 9. You could do that. 4.5 and 9 is also another data point. Just make sure that you get it from the first 4, because I'm actually looking at change of the voltage and the current over here, but change of the voltage and the current. Next, the voltage is going to be fixed, so that's why I'm not going to put that data over here. Okay, so then I close it, and then I look at the curve. Yeah, here we go. Here we go. So here is the curve that we have. So what I want you to do is to find the slope. It is basically rise over run. Just look at it. For example, rise over run is that rise of, if I go to this point, rise of 12 is going to give me the run of 6. So 12 over 6 is going to be 2. Pretty much like this. I mean, I have actually put it over there for you to see that. I mean, I have already found it for you, but I want you to do it as well for me. You say rise over run. I found it from here. That's how I calculate it. And then 1 over 2 is going to be 0.5, which is 0.5 kilo ohm. The reason is that over here we had put the data in milliampere. If you see over here, because the current was in milliampere, the resistance is going to be in kilo. So 1 over 2 is going to be 0.5, but 0.5 kilo, which is 500 milli 500 ohms, as you see over here. If I had gone back, which was the case. Okay. So what I want you to do is to go through this lab and then answer the questions that I have asked. And if you have any questions, you can leave a message on Blackboard or send me an email. Thank you.